All right, so yeah, welcome to the Data Science Mentor Program. The Data Science Mentor Program is brought to you by me, Pablo, the founder, convener, and host of the Data Science Mentorship Program cohort. Right, we're typically building data science skills using examples and also mentorship. Now, I was saying before we had a little bit of a technical glitch. Um, the AI, we're at the period where AI is such an important feature in solving human problems. And there's been a lot of hype around AI, but the reality is your data science is basically the foundation for everything, a lot of the things that are happening in the AI space. And to make sense of it, it will be ideal to understand what the foundations are. And in today's session, we are looking at support vector machines. Remember, the idea is to predict, to make predictions. Making predictions has a lot of components to it, which means you're taking data, you look at historical data to tell what will happen in the future. Now, what we do is take statistical models or functions or equations wrapped up together. Typically, in the past, I'll say wrapped up in a black box, but it's no longer a black box because there's something called explainable AI. So that's a different scope, right? And so it's wrapped up, and we try to predict what will happen in the future. But largely, a lot of the feature engineering is up to us. We are also going to get to a point where we may not have to do a lot of feature engineering. We'll just legislate that to compute resources. But again, how to manipulate layers and neurons will still be up to us. But today, we're starting from from the basics again, as usual. Now, what we've been doing is we have looked at the basics of linear regression, did a simple deep dive. And now we're looking at support vector machines, and support vector machines, help us draw boundaries around features. And if you've not seen this, I would suggest you can check out support vector machine, which is the 24th session in the machine learning resources we have to check out the idea behind the support vector machine. And we're building from what we've done before. And today, what we're going to do is we're going to build margins. We're going to build margins around this area aspect. Here we've drawn lines to separate features. Right now, what we're going to do is we're going to go from just drawing the lines, right, to now drawing margins. Now, when we draw these margins, what will these margins do with respect to two features? Again, think about this feature. If you look at these features here, what are they? Let's assume these are email address, emails that you received, and we're trying to classify them, spam or no spam. And I come over here and I draw these lines and I say, look, I think by breaking these lines, bringing these lines together, we can separate this. But then somebody steps in and says, well, I think we need to create some level of margins to this so that if there is some space that we are able to say, with these margins, we can tell the features that are close by, and say, oh, these features that are closer, right? So we're sort of saying, let us create some sort of a width closer to the nearest point. And still, we're trying to do this by, typically writing code and abstracting this. Now, the whole idea is to gradually get to a point where we say, okay, you know what, let's let the support vector machine do its work. So the next thing we're going to do here is we are going to build on what we've done and then build margins. Now, like I said, it's interesting to follow this setup because you would learn how to write code and use code to visualize ideas. Now, let me see. So the next thing we're going to do is we have built a few things earlier on. did a few things earlier on. We created something called line boundaries. So we're still going to work on the line boundaries still. So now we're going to create another line boundary, the same line boundary we had here. Again, I love to do a continuation from the last session. So, which I'll start here again. I'll copy this, and I'll use this line boundary here. Now, this line boundary consists of numbers, linear. That's see over here. This consists of evenly spaced numbers, right? The next to do is I will plot a scatter plot, right? When I plot a scatter plot, I'll go on to create boundaries. I'll create some form of margins around these lines I have created here, so as to see if we can maximize this line we have and say, look, there are going to be points that are closer to these features, and is that even important? Does that tell us, the difference between these two features we're looking at? Now, again, remember, just if you're joining in, the idea is so that we can see what we can do abstract by writing simple code, which is typically what heuristics are all about. Then go on to say, okay, let's leave it for a model to do its thing. So I'll start off by, all right, plt.scatter. Also, we're going to view the scatter plot. Now, the difference between this scatter plot again is that we're going to just draw some sort of like like margins and then sort of like shades to it to see see if we could get some idea. Now, so the scatter plot is typically going to be X and Y. Now, again, if I use X, it means I have created X from the outset. You can see I use the blobs. Blobs are like sort of like data points you can get off the sklearn dataset class. So the blobs make it easy for us to create like two sections, so we can classify them into two sections. So I'm going to visualize the blob again, right? And I would use X, which at this point, you remember, at this point, X is our feature matrix. At this point, if you're asking what's a feature matrix, I would advise you just once you look at your resources, just take some steps back and say, okay, you will see that it is indexed for you to understand what we're doing. Maybe you just have to go through the introduction to sklearn or scikit-learn to understand what feature matrices are. So here we are going to look at our feature matrix and get one part of our matrix out. And this is typically what creates the division you see. Then we have X again, and then we get the other side. So we're going to create a division, and this division is going to be used by our target. Then size, and we'll put a color map. Now, the interesting thing about C maps and color maps is if you sort of feel like you don't understand what that means, just take a brief walk. Just take a little walk to Introduction to Data Visualization, right? You'll see that all the things you need to understand about that is there. Now, I'm going to write a for loop. Now, what the for loop will do is it's going to, get through the boundaries we've created earlier on, like these boundaries. We're going to get through these boundaries, and we're going to sort of create shades around these boundaries. So I say for M, B, and D, which is our representation of our boundaries. And we're going to say in So create a list filled with tuples. Now these tuples are going to be representations like boundaries that we have created. So we have 1, 0.65, 0.33. Next, we have another tuple containing 0.5, 1.6, 0.55, and another tuple containing minus 0.2, 2.9, 0.2. Then we'll close this. Now, what we're going to do now is we are just a bit so I don't confuse myself. Just a bit. All right, so we're going to now create another boundary here. Now this boundary, I'm going to call it the Y line. Let me call it the Y line boundary, so to speak. So say I'll call this Y line. Let me call it the Y line, sort of a representation of the X and the Y, sort of like the representation of the Y in a way. Now inside, I'm going to say M multiply. So which are all these boundaries you see? 1M multiplied by the line boundary. This line boundary here plus B. Now you know what we've done here. Again, if you started from scratch, you realize that M and B are typically the two features for which we're like saying the slope and the intercept, which basically says when we start from scratch, what does it mean? And also the slope and the intercept are always asking us when we start from scratch, what value do we have before prediction? And for a certain movement in our prediction, what would that mean with respect to Y? So it's just those are really important setups when we get started. Then trying to be really careful here. So we have plt.plot. Now that means at this point we're having two plots in one. So here I'm going to have my line boundaries, and I am going to have my Y line, and I'll subtract from what we have here, which is this part. The idea would be for us to create some sort of like an edge that makes sense. So with our edge, you say our Y line plus D. So you see we have subtraction and an addition going on for both parties here, right? So that is what we're going to have, which is sort of will create something like a shade. So we have an edge color, and inside our edge color, we just basically put none, and just put here then color. We will have light gray, because that's what we're going to have in our edge. And then we'll create something called, we'll have alpha. By this time, we realize whenever we introduce alpha, the alpha feature basically tells us how much transparency do we want to have in our visual. So we have 50% transparency. Then we can now go on to say PLT dot xlim, which is the limit we're going to have, and we're just going to represent this with the same lane space you have here in here, which is our line boundary. Then we should now say PLT dot show. Again, forgive me, if it turns out to be sort of like an error, we'll have to look out for the error and solve the error. So no, unexpected edge color. Yes, where did it get? Mine today got an unexpected keyword argument, edge color. Yeah. I'm just curious, why would it say it got that? What am I even doing? Plotted. Okay, I think there's an error here. PLT.plot. And here we would have our line boundary and our Y line, because these two things are really important. And then we would have an indicator, we would have this. I think this is what we missed. Now, if this is what we missed, what does this help us do? So this is PLT.plot. This plot is okay. So this is supposed to be the in-between. So there should be PLT. So PLT dot. There should be something called in between fill. I have to look up my notes, so that makes it really easy. Let me just look through here and see if I'll find anything. Yes, I think this is it. Fill between is a function. Yes, fill between. Yes, here. I remember vividly fill between, and what fill between will do is within our line boundaries, this is all what we're going to have. Okay, so let's try that again. Yes. Now, you see, what we have done here is we have taken two steps. In the first step, we just drew our line by ourselves just to separate our two features. And remember, like I mentioned, these two features could be anything. It could be, this could be your email, and you're trying to separate emails from your spam from your emails. This could also be your you applied for to do your master's program in one of the US universities, and these are one of the features to to predict if you are going to be accepted or not accepted. Right, so sort of like a demarcation. So we're trying to do it ourselves. And so with this, we now see that we have margins. We've created some margins, which says, okay, you can see now we've created this margins. Now, what this margin has done is that it has created a discrimination between these two. Now, if we look at this, we can now, at this point, this is where we can say, can we, what can we do, in essence, what's the difference stuff we can do with a machine learning model that makes it important that we use a machine learning model rather than try to build these decision boundaries, all these boundaries you see by ourselves. So now what we'll do is we'll build a model. We would use a model to see what's going to be different. That's what we're going to do now. We're going to use a model to see, okay, what's going to be different with what we have done. And then from this point, what you would get to see is how models think differently from how we will typically write the rules to classify the data we have. So to this end, let's introduce the support vector machine. Now, there's something I want to say, and I think it's very, very important. Every time we build machine learning models, there are ways to explain these machine learning models. There's an explanation of all these features. There are different techniques for doing this, right? So it's not something, again, if you were at the beginning, I'll say, look, it's not a black box in any way, shape, or form. It's not a black box at all, right? Again, it's called explainable AI, and we haven't gotten to that point where we got to explain stuff about our data. But what we're doing is the steps we're taking. The explainable AI side of things is the point where we say, look, what features, were really important to making certain decisions. Because of course, we have to, at any point, control some of the situations, right? Or control some of these variables, or understand, not control, but understand the way these decisions were made, so we can pull out features we think really, move the needle. All right, so first things first, I'll introduce the model class, which is sklearn. sklearn.sbm. And here we're going to import SVC. So that's the first part. Now, the next part is we are going to instantiate our model. So here we say SVC, and inside, so of course, again, like as usual, we have really, our interesting defaults we have. We're going to be looking at two things. We're going to be looking at kernel, and we are going to be looking at the C. Now, the C is a parameter, regularization parameter, which is, we've talked about regularization before, so you could check that out. But we're going to put a regularization parameter here. So we're going to use a really interesting regularization parameter, and we'll talk about what that means. But first, we say kernel, and we'll look at, we want to do a linear classifier. C, and we're going to introduce, like, we'll talk about this later. And then I'm just going to fit the model. Model.fit. And remember, we already have our data, and this was the data we started off here. We can see at the beginning we had our X and Y. So we've had this data, which is what the reflection you're looking at here in the visual. So we're going to say X, comma, Y. And again, remember, this is for teaching purpose, for the instructional purpose. Most times your data you have to create a cross validation so that you could test your model across, just to understand the consistency and somehow the faithfulness of your model. Is that the word? Or to understand, so that you know how well it's training, because that's a different conversation. But yeah, that's the point. Now, this is what we're going to do. We'll run this, and so you can see what it means when we set our regularization. This is what we try to do here. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what we did. All right. So next, we are now going to visualize what happened in this setup, right? And again, I have to shout out to a lot of books I had to read for me to come through this thought process, right? So first thing I'm going to do for us to visualize it, I'm going to write a function. So so here, let's visualize the the happening. So let's visualize the happenings. And at the end, we'll just look at our three visuals and we'll look at all we've done and then look at what a model would have typically done, which is this model here. Now, first thing is we'll define a function. So we're going to define this. We're going to call this, what are we going to call this? So let's say plot underscore SVC. Plot underscore SVC underscore function. Let's call it the plot SVC function. Now what it does is that it's going to take a model. By default, we're going to put the model there. Then axis is going to be none if we choose not to put anything. Then we're going to say plot underscore support is going to be equal to true. In case we need that, and it's going to be there. Now, next is we are going to say if X is none, this is what should come out. We should say X is equal to PLT dot what's that? PLT dot, yes. This is basically get current access, yes. That's what it is. So we don't have anything, it's going to get our current access. We're going to determine our X limit, which is our X-axis limit. And our X-axis limit is going to be X dot get underscore X limit. Same with our Y-axis limits, which is going to be X dot get. I'm going to make this a Y limit. So it's just going to get, when it doesn't see anything, it's just going ahead and to do this. Next, we're going to evaluate the model. So here is the grid that evaluates the model. Now, we're going to create a bunch of stuff, right? We're going to create stuff so that we could understand what we're doing here, right? Now, there is something called, when we fit our model, which is this, right? Then we put a type here. There's something called, this is, the SVM, right? Now, inside this model, there's something called our decision function. Look at that. So it's basically, it contains an X, it evaluates the decision function for the samples in our historical data. So how it evaluates the decisions that were made inside, which is sort of trying to understand how it's going to separate these values we have here. So I want you guys to pay close attention to this. Now, what we're going to do is we are going to create X here and say mp.lane space. Now, at this point, you get to understand why from the outset it is said that understanding NumPy is huge in the data science space. It's like data science is NumPy is the foundation for data science. In fact, when you take it a step higher or it's advanced to deep learning, and let's say you're using the PyTorch deep learning framework, you're going to be using tensors, and tensors are typically like, NumPy on steroids, so to speak. So it's important to make sense of NumPy It's a learning curve, so it's something that never ends. So you just have to keep learning it from scratch. And it really interesting thing in the data science network program, we have a whole session dedicated to introduction to data analysis with NumPy. So please feel free to go through that and see what that's all about. Now, lean space here we have xlim, which is what we have over here, and then here xlim1 here. So you see what we are doing here is that we're taking whatever comes out from this stuff here, and then we're just going to create like 30 elements from them, right? Then we have y, which is going to be mp dot. Now what I'm going to do is I'm going to copy these guys so I don't get to write this code over and over again. And the difference is this is going to be y and this is going to be y. Now we're going to have y comma x, which is we're going to create a mesh mp dot mesh grid. Again, show you what it is. Returns a coordinate matrix, so it just basically has like a vector like form of grid. And inside of it, we are going to say x and y. So see what we're trying to bring. Then we go on to say create xy, and xy is going to be mp.vstack. Again, what does vstack does? It's a stack. It's sort of like brings stacks arrays in like sequence vertically or row wise. So we're just going to bring what we're going to do with the vstack is that we're going to take the x we have here, this data, and we are going to have x over here. We'll flatten it, and we're going to have y dot. What we're going to do is we'll have this called Rabble. So we now have one of our data points, and we now have sort of like another data point on this side. But you will see what we'll do with the y side of things, right? Because we're sort of like creating a grid as we follow each other. So it's sort of like we'll follow whatever boundaries we are creating for x. And once it does that, it's sort of like a grid. That's what it's going to do. Close. And then once we do it, we'll transpose both of them. So they kind of like be like they're supposed to be like this. We will now turn them to face this way. Now we'll now say P. We're going to say P. And what we're going to have in P is going to be our model. So we're going to have model dot decision. Oh, sorry. Model dot. Why am I doing this? Model dot decision. Model dot decision functions. I think that's what I showed you guys here. Model dot decision underscore function, which would typically tell us, okay, what's going on here. So here we're going to now take x and y. So it's sort of like tells us how the boundaries, what decision we made in terms of the boundaries itself. Then we would once we do that, we would reshape. And when we reshape it, we would say x dot whatever shape x is, it will reshape into that. Right. So we have this. Now the next we're going to do is we are now going to plot our decision boundary. Now remember we have our axis here, so we're going to say ax dot contour now. When we say ax dot contour, what we are typically interested in is the x and the y, comma, we will also say p. What we're going to represent all these guys in a bit, right? This is a capital P, okay, and P. Now, what this means is we're going to put a color here, and then color is going to be, this should be K. K should represent black. So, and then we're going to have the levels. Now, mind you, a lot of these things might be new, but again, just understand that I am walking through this situation while talking myself through a little bit of it. Big plus how much I took time to understand what this is. So again, we'll have alpha, depending on the levels we're having. We're also going to have line style. We have line styles, and line styles are going to represent, we'll have a list containing dashes, comma, single dash, and double dash again. I think that's let me close this. Now, the next is we are now going to plot the vectors. So plot. We'll plot the SVM, the support vectors. So let's call them plot the support vector. Now we say if plot support, remember when we did plot support, right? So we now have act.scatter. Now in this scatter plot, we're going to now have again, just so you know, all this, the model.support is also a thing, right? We have model.support vector, again, an array that represents multi-dimensional arrays, right? Associated with the data type objects based on what we're working on, right? So we would come here and we are going to call this. Now we will do this and put a square bracket on top of this. Because we are doing a classifier, it is important to understand we're looking for like true, false, or 1 or 2, right? Second, we are now going to look at the next model. Yes, and then here we are going to go on 1. We have S size 300. We are going to have line width equals to 1. Also, edge color, I've written this before, that will be black. And we can also have base color, which again, I would ask for you guys to forgive me if I end up having some form of error here. Okay. Now the next we are now going to do is I'm now going to say ax.set underscore set underscore x limits, and it's going to be x lim just from beginning. Then we have act.set underscore and it's going to be again while. Then right after we have done this, we're now going to step out of this area and we will now plt, let me give it some space, plt dot scatter. Inside it, we are going to have x, take 0. Next, we're going to have the x 1. Then c is going to be equal to y. It's typically what we had. Basically, this code I'm plotting here is basically what we used to plot this guy in the very beginning. It's like saying, it's like calling this guy again. And we're calling this guy, but whatever we're going to have inside is going to be what we have, the decision function, what the decision function has seen. Then for us to work with it, I have to now plot our SVC function, and then I'll put the model inside. And then with that, I can now say plt.show. Now I'll run this. Look at that. So you can see that as I run this, I'm missing one guy here that's supposed to, oh yeah, it's there. It's there. Why is it dark? You can see it's here, it's white. Feels like I got the wrong color. Did I use the wrong color? Which color? But there's a line here. Let me see if there's a place where I was supposed to make it have a different color, and I missed out on this. This color as well. That's okay. Just to be sure I didn't mess up, but there's no error. But at the same time, I'm looking at it and wondering why I didn't get the colors that worked. I'm looking and say, why didn't I get the right colors? There's supposed to be a black color somewhere. I'm wondering why. But again, this is what it is. We have gotten our colors out, and I'm just taking my time to see if I missed out on one of the colors that was supposed to be there. The contour shape. Why is this? Why? I want to know why on earth I'm having this error. I'm not just satisfied that it didn't come out as expected. There's supposed to be a black line. All right, so guys, so this is what it is. This is what it is. Now, typically when you code live, sometimes you might miss out a few things. When it comes to colors, let me look at the colors. Contour AHYP. Oh, I see. Okay, let's try this again. You can see now, you can see that this shows up, right? So you can see now, like the boundaries are being picked out, but we still have something going on, right? Look at that. then are we missing out on a few things in terms of did we miss out on the way the boundaries are going to show up? Did I miss out on that? Because we are supposed to have some limits to it. So did I miss out on how the limits are supposed to be? Because it's supposed to work in a way that works. You can see that these are not complete, and I'm wondering why they're not. All right, so yeah, so I'm going to just pay close attention and just to be sure we haven't missed out in terms of boundaries. We have missed out on anything in terms of boundaries. So but yeah, so you can see what the model looks like. It sort of tries to capture the boundaries in its way and tell you, look, there is spaces and boundaries in between, but there must be something that didn't work, right? But you can see these are all the stuff we have worked on. I'm just trying to look at the boundaries and be sure there are no missing boundaries to what we try to visualize. But yeah, so um, so you can see we have all that there, and we visualize them, and we have also introduced our different boundaries to it, and have gone on right to see that this works pretty well, right? Just checking, just to be sure I didn't miss out on anything, right? But that's basically what this has done. It's just sort of like introduce that, let us know we have boundaries. These are these two. These are the support vectors. They are very, very important in the grand scheme of things, right? They are so important in the grand scheme of things. They tell us where the boundaries exist. For instance, you can see this boundary here, right? You can see these boundaries all exist here. See this red boundary. This is like you can see the different boundaries exist, and these boundaries exist, and you can find these support vectors as is. Though it's not, it would have been okay if this thing came here. I'm trying to be sure that I didn't do something earlier on that sort of messed up our work. But whatever the case is, this is what we have. Okay, we have px x y limits. But yeah, so in essence, this is it, and it tells us that. And just to take it a step further, we can see the decision, the support vectors. So you can do that by saying model dot support vectors. These are the support vectors we have. This is an array with different support vectors that try to get an array to say, oh, look at where the vectors are. Yeah, so these vectors are here, and it's sort of like they're what will typically tell us the different points, sort of like the calculations that it identifies the different points, stores them, and all. Right. So I mean, there's a lot to it, right? You can even decide to train a new data set, a new data point on it, and you can see the different decision boundaries that will be created if you improve on your data points, and you see that. Now, the idea here from all that we have written is the data points we have and the boundaries is this is visually how the SVM gets to to determine the different boundaries for which it can classify different features and say, for X, these are the features that are here and that. So what it means that in future, if you are building a model, you have it at the back of your mind that there are going to be boundaries that are created. Again, because we don't cover that in this our introduction in data science mentor, the reality is you'll get to a point where you have to explain each feature, each the input or the role every feature played in your model. It's like a feature importance visualization, but to tell to what end every feature played a role. What that does in essence is it tells you, look, if we were going to give admissions, what features would be important? Maybe CGPA will be right on top of that. Maybe your GRE score will be next. Stuff like that. So, but again, remember, these features will almost always be there, right? So that's this is it for margins, and using the support vector machine to now basically look at the different margins we have. We're going to do another technical step forward where we would basically visualize, use a different where you use a different technique this time around for using support vector machines to understand it's like trying to use polynomials, right, where we are sort of going to be tweaking our model in terms of what if our data does not actually, what if the boundaries can't actually capture the models in an ideal fashion, or capture the features in an ideal fashion? What do you do? In linear regression, we introduce polynomial features in order to find the different curves, even though that would have come at a cost. Sometimes it might overfit just because it's doing that, and when it overfits, you not introduce like a regularization, so to speak. So we're going to look at another technical step. The idea is to remember technical steps, reality, not a mindless repetition of it. So yeah. All right, guys, if you have any questions, feel free to ask it now. If you want to watch this again, you can also drop the questions in our private Telegram channel, and we can jump on a call to make some clarifications and all.